The fifth part of lecture number 2 is capillaries. Before we go to the Fibry diagram of this behavior, we back to the previous clip about the surface tension. So this clip shows the floating rasa braid. When we put on the surface, it can stand on the surface of water, and we increase the force acting on this braid is moving down. And the next, we put another braid that's very heavier braid, cannot stand on the water surface because of its the weight. The other clip is about the capillary rise. Let's put a small different tubes from the bigger tube to the smaller tube to the contact with the water surface. You see that the capillary rise into the small tube. Smallest one gives the highest capillary rise. So that's about 0.15 millimeter of diameter. It gives about more than 2 centimeter of the capillary rise in the smallest tube. Again, we can explain what happened for the capillary rise in the small tubes. If the water, in this case of water, we expect that this is H is capillary rise in the when we put the small tube to the surface of water. And in case of the mercury, there is the opposite way. This H is below the water's surface. Okay. Next, we can draw from part B. From this, we can draw enlarge the Fibry diagram of this the capillary rise, and the volume of this capillary rise is equal to pi r squared in case of H. So we can change to this one is capital R. Okay, and the mass is equal to m. So we can substitute the weight of this is equal to weight is equal to rho times volume times g. So we got rho, substitute the volume pi r square h and g. So that is the equation 2. Okay, weight is equal to rho pi r square hg, and F is equal to 2 pi r sigma cos theta. So make equilibrium between two equations, and we can prove that the capillary rise is equal to this term. And you see that the height is the inverse proportion to the radius of the tubes. If the smaller diameter gives the higher capillary rise. Okay. And this case it shows if we have the fluid in between the plate. Okay. For example, this is a plate on the top and the bottom, and the fluid in between, like a glass and the water in between. So because of the surface tension, you have to apply the force to take the plate, separate the two plates. Okay, and we can draw the Fibry diagram of this fluid. You see the different pressure P1 and P2 between outside and inside the fluid, and this is for for surface tension force, we can write equation for this equilibrium. Start from F. F is a different pressure between outside inside fluid times the area. Area is the surface of cylinder is equal to 2 pi RT. Okay. And for the F is equal to 2 times the 2 pi R sigma cos theta. And the next we can make equilibrium between two equations. Equation 1 equal to equation 2. 2 pi RT equal to 4 pi sigma cos theta. And we can prove that delta P is equal to sigma cos theta divided by T. Okay. And finally F is equal to pi R square delta P. And the next table show the property of the water and air. For water, that we explain that water is a Newtonian fluid, so the viscosity decrease with the temperature. For example, this 1.7 10 power 5, but once the temperature increase to 100 degrees C, the viscosity decrease. Okay, and the other property is for air. Okay, air is opposite. Once the temperature increase, the viscosity decrease, increase. That is 1.5 to 5.0 10 power minus 5 for the air.